Okay, so let's look at 2017 2B. This was a kind of not a very nice question. So what do we have? We've got ship P is moving north at 15 kilometers per hour. So I've got north, south, east, west axis here. VP is moving north. Second ship Q is 10 kilometers west of P. So I'm going to put Q over there. P is at the origin. And it says, P appears to be moving Q appears to be moving relative to P in the direction east 60 degrees south at 15 root 3 kilometers per hour. So this red line represents the relative velocity. So it's Q appears to be moving. So that's going to be the 60 degrees, and of course the speed of it is 15 root 3. So find the velocity of Q. Okay, so we know that VPQ is equal to VP minus VQ, and of course actually this one is VQP. So VQP is equal to VQ minus VP, which means that VQP plus VP is equal to VQ. So I have these two, I'll get them in terms of I and J, and then that will give me VP, or VQ rather. So let's look at VQP. Here, that's the red line. So I'm going to draw a right angle triangle around that red line. This is the I component of it. This is the J component of it. Okay, so the I component of that VQP, the speed I'm told is 15 root 3. So it's going to be 15 root 3. This is the adjacent side and it's in the positive I direction. So that's cos 60 on the I. Now the J direction is going down the negative direction, so this is minus 15 root 3, the sine of 60 on the J. And when you work that out, you get 13I minus 22.5J. Now, of course, I know the speed, but I don't know the direction, so I'll just figure out the direction of it. The direction, of course, this is the vector it is, so it's positive I, negative J, so it's heading in that direction. I'm going to get the direction here, which I'll call alpha. So the tan of alpha will be opposite over adjacent, which is the J component over the I component. And when you work that out, you get 60 degrees. And while we're at it, we'll get the speed. So VQP is equal to, the speed of this would be the square root of the I coefficient squared plus the J coefficient squared. And when you do that, you're going to get 26 kilometers per hour. Okay, so you have all that information. Now let's go back here and find VQ. So to get VQ remember is VQP, which is this one, 13I minus 22.5J, plus this time, plus VP, and VP of course is 15J, so plus 15J. And when we do that and we work that out, we end up with 13I minus 22.5J plus 15J will give me minus 7.5J. So that is the velocity of Q. I could find the speed and the direction, which maybe I will for good measure. So to get the speed of it, remember, of course, it will be 13 squared plus 7.5 squared, and the square root of that, which will give me 15. Oh, sure, I know that. I know it's 15 kilometers per hour. I was told that in the question. Now, the direction that it's going in, the direction that Q is going in, of course, is arctan 7.5 over 13. So second function tan 7.5 divided by 13 gives you an angle of 30 degrees. Okay, so, and of course it's positive I, negative J, and this VQ, so it's positive I, negative J, which will be heading east 30 degrees south. Okay, that's its direction. Even if I'm not asked, I'd get it anyway. Okay, so find the velocity of Q. Now it says, 2 minutes after the time when P and Q are closest to each other, P is east theta degrees north of Q. find the value of Q. So you need a nice big diagram for this one now. Okay, so we're going to draw, here's our axis again. Okay, so what do we have? We've got Q over here, P's at the origin, and they're 10 kilometres apart. This is my relative velocity line. I'm going to pass that through here again. I know its direction, or I know the angle that it makes with the positive sense of the y-axis, or the y-axis is 60 degrees. Okay, now if I was trying to find the closest distance, what I would do is, of course, drop a perpendicular from P down onto it and get the closest distance. I know now that this angle here is 60 degrees, so I can put that in here. And using that 10 and the 60 degrees, I could find the closest distance. And if I did that, I would get that D is equal to 10 times the sine of 60, which, if you do that, you get 8.66. So our closest distance between the two would be 8.66. 2 minutes after this closest distance. So let's say you go on for 2 minutes and you end up here. So this is after the closest distance. So I'm going to connect these two bits there. Now, 2 minutes after the closest distance, P is east theta degrees north of Q. So this is kind of a strange bit here. Okay, so P's up there. So give its direction now relative to Q. It's east theta degrees north. So here it is, there it is. Theta degrees north. So you've got to find theta. That's what you're asked to do. You're asked to find that angle. Okay, so what do we have? We've got this 8.66. We know that that red distance, that little distance there, I'll call it x. So we know that x is the distance travelled after 2 minutes. So distance travelled after 2 minutes would be 2 over 60 is equal to x over 26, 26 being the speed. So this is time, so I'm using the speed equals distance over time link. So this is time is equal to time is equal to distance over speed. So the distance that you've travelled is x at that relative speed. And when you do that, when you fit 2 over 60 because it's 2 minutes and everything's in kilometres per hour, when you do that, you get x to be 0.867. Okay, so now we have these two. We know it's this, that. When we dropped the perpendicular, that was a right angle. So now we have these two distances here, which means that we could find this angle, which is inside that green triangle. So knowing x and knowing d, I could find this angle here. I'll call that alpha. Okay, so I could find this alpha, this red alpha. Okay, so to get red alpha, the tan of alpha is equal to 8.66 over this distance here, which is 0.866, and that gives me nearly 10, which means that when I do a second function on that, second function tan on that, I'll get 84.29 degrees. Okay, so looking at this series of triangles here as well, look at my corresponding rule. So here, if this is 60, this angle here is also 60, isn't it, down there? So I have alpha, I have 60, so I can get theta. So alpha is 84.29. Of course, I'll add 60 to it, and theta, if I add 3 of them, I should get 180 degrees, which means then if I add those and take them from 180, this means that theta is 35.7 degrees. Okay, so that was the first part of the question. Or the second part, the velocity of Q was the first part, finding the value of theta was the second part. Now look at the third part. The third part says, if Q can be seen from P for 12 minutes. Okay, so I'm going to redraw this idea here again. So here's my axis. and draw a nice big diagram so you can see what's going on. This, of course, is my relative velocity line again. Now, I know that this is the closest distance. I've already found that out, so I got that to be 8.66, so I know what that is there. Okay, so this is my D, and I have all my angles and everything. So it says Q can be seen from P for 12 minutes. Find the distance between P and Q at the end of this time. Okay. So if this is P, if P can be seen from Q for 12 minutes, what I'm going to do is draw this kind of idea here around there. And from P to where that cuts the relative velocity line, that distance is the one I'm looking for. I'm going to call that Y. So you want to find Y. Now, that will happen when after 12 minutes, or it will happen for 12 minutes. So I could say that if I was normally doing this, I'd drop a perpendicular down to here. Okay, that distance, of course, would also be Y. I have this D there, 8.66, and I would call those two values there maybe A and A, because I've already used X, so I'll call them A. Now, the time that this is going to happen for is 12 minutes. So if I use speed is equal to distance over time, then the time is equal to the distance, which of course will be 2A, over the speed. And this is all from the red line. So it's all from the relative velocity line. So the time that it happens for is 12 minutes. I'm going to turn that into hours, 12 over 60. Now that's equal to, the distance is what I'm looking for, of course, which is 2A, over the speed of that red line, which I found already here to be 26. So I'm going to divide that by 26. And when I do that, I've worked that out and I get A to be 2.6 kilometres. Okay, so I have A, I have D, and now I can find Y. So by Pythagoras, I'll get Y. So Y squared will be equal to D squared plus A squared. And I'll put those values in there and I'll get Y eventually to be 9.04 kilometres. So that's how long, the distance from which they can be seen from each other by.